Good morning. This is your Stats Sensei, Mr. Spensei, and this is on the binomial distribution. This is Congo infected with the Ebola scenario. So use the following scenario. The death rate in the Republic of Congo for those who contracted Ebola was 90%. We're going to have to assume that that was independent and remain constant. We have a group of 93 infected people. So what is the probability that 82 died? Well, first off, we have a group of 93. So that's my number of trials is 93. My probability is 0.90. And we're going to assume that it was independent, that one person getting it didn't impact anyone else getting it, which I don't know that that's true. And we're going to assume that it was a constant rate. So if it's a constant rate, always at 90%, this makes it a binomial. So we need to name that it is a binomial. So here we go. It's a binomial with n equal 93, a probability of 0.9. So trials is 93. The next thing we need to do is define x. Well, what is the probability that 82 died? Let x equal the number of Ebola deaths. All right. So my number line, I can always start at 0. That's part of the bison. 0, 1, 2, 3. There's no way I'm going to go all the way up to 82, dot, 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 81, 82, 83, dot, 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 all the way up to 93. There we go. But it says probability that 82, that's specific value. If it's a specific value, I am going to be only go, oh, I only circled one value. One value circled, this is the formula that I'm going to use. And this is my probability statement. So my probability statement is going to be the probability that X equals 82, 82 deaths. All right. My formula is going to be N choose X, P to the X, and then 1 minus P to the N minus X. The only difference between this and multiple values is multiple values will have a summation here. So the next thing I need to do is I need to plug in. Well, my sample size is 93, so that's my N. So 93 out, and we want 82 is our X. And we have 0.9 to the 82nd, 1 minus 0.9, and 93 minus 82 is 9. So that's our equation. So second vars, binomial PDF. I don't need to go summation because we only had a singular value. The trials was 93. The probability is 0.9. We want to know the likelihood that 82 people died. And we find out, oh, about 10% chance it is exactly 82. Now, it could have been 81 or 84. All right. But the chance that only that exactly 82 died is 10%. So equals 0.1078. All right, the next one. What's the probability that no more than 82 died? Well, in this case, we're looking at 0, 1, 2, dot, 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 81, 82, 83, dot, 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 all the way to our group of 93, which I'm not going to rewrite, but we said no more than 82. So it could be any of that. It could be 0 died or 82 died. And remember, N is 93 and P is 0.90. In this case, I have multiple values circled. So multiple values circled. Oh, and I'm not going to redefine it because we're looking for the number of deaths. We've drawn the graph. We've done this. But we have more than one value. So my probability statement. My probability statement is going to be the probability that X. Now I could write it this way. I could write it probability that 0 is less than or equal to X is less than or equal to 82. But generally speaking, if 0 is involved, we just do probability that X is less than or equal to 82. Probability that X is less than or equal to 82. That's better. And my formula is going to be the summation because I have multiple values. The summation is going to be n choose x, same formula, just with the summation because of the multiple values, p to the x, 1 minus p to the n minus x. So in this case, we're going to have to start with our lowest, where our lowest is 0. So we're going to say 93, choose 0. The death rate is 0.9 to the 0 times 1 minus 0.9. That's the people who survived. And 93 minus 0 is 93. Plus dot dot plus. Highest value we circled was 82. 93, choose 82. 0.9 to the 82nd value. And 1 minus 0.9. And 93 minus 82 is 9. So let's go ahead and do this. Now, this one, we can't just do second vars. We have to go to the math button first to get the summation. Math, summation, x over 2. Our lowest value circled was 0. Oh, no, it's not. Yes, it is. Our lowest value circled is 0. Our highest value circled was 82. Second vars, binomial, PDF. Trials is 93. Death rate is 0.9. And we're interested here. I can't have X value. I have to choose X. So I press the center, that XTON button right there. Get X. So anytime you have the summation or multiple values, you're choosing X. And it's doing some thinking right now. Apparently, it's having a hard time. So 0.3253. So in this case, there's about a 32% chance that 82 people or less died. What's the probability that at least 82? So in this case, we want the probability that X is greater than or equal to 82. And we could have written it also, not just like this, we could have written as the probability of 82 is less than or equal to X is less than or equal to 93. And we see that because we can go 0, 1, 2, dot, 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 81, 82, 83, dot, 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 all the way up to 93. And we have to have at least 82 all the way to 93. And that's what this says, between 82 and 93. So if you prefer to write it that way, that's fine. I'm not going to rewrite the summation formula. That's it. So here we have 93, choose 82. That's the lowest value we circled. 0.90 was the death rate raised to the 82nd power. 1 minus 0.90. 93 minus 82 is 9. Plus dot, 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 plus for all the numbers in between there and 93. The last one is 93. Choose 93. And 0.90 to the 93rd. 1 minus 0.90. And 93 minus 93 is 0. So, math, summation. We press X. The lowest value we circled was 82. The highest value we circled was 93. Second vars, binomial PDF, and trials is 93. Probability of death is 0.9. Our X value, we're just using X because we have the summation. We get 0.78249. So 0.7824. Okay, last one. What is the probability that at least 68 and no more than 86 died? So 0, 1, 2, dot, 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 67, 68, dot, 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 85, 86, 87, to 93. Well, what am I looking for? I'm looking for between 68 all the way to 86, at least 68 and no more than 86. So, probability that 68, probability, yes, that 68 is less than or equal to X is less than or equal to 86. Please note the your probability statement comes straight off of your graph, your number line. I'm not going to rewrite this because we already have done the summation, and I know it's a summation because I have multiple values. So I always have to start with the lowest, and the lowest one is going to be 93, my sample size, choose 68. Probability of death is 0.90, zero point 0.9 raised to the 68th power times 1 minus 0.9. 93 minus 68, I don't know what that is off the top of my head. 93 minus 68 is 25 plus plus 93, choose 86, 0.9 to the 86 power, 1 minus 0.9, and 93 minus 86 is just 7. Math, summation. We're going to press X. Oops. And we have 68 was our lowest value we circled. Highest value we circled was 86. Second vars, binomial PDF. 93, a group of 93, 90% death rate. We have X. And there's about an 83% chance that we'd have between 68 and 86 people die out of a group of 93 who were infected. So pretty high probability that this is where it's going to be, that number of deaths. I sure hope that helped, and I sure hope to see you on the next one. Thank you for watching. Talk to you later.